crash for a bit?
Yes, in the beginning it did. All right, so today what we're going to do is go over methods. Now this is something that should be a refresher for you because you guys have spent time in your COP 1000 going over functions or methods. And functions and methods are terms that we use interchangeably, and both of them are the same thing, so functions and methods. And when we were looking at the classes and objects, we looked into constructors. Remember, I kept on saying constructors are nothing but methods, but they're kind of a little special kind of method because they always have to be named according to the class, okay? But I also talked about how we can create a signature of a method. Now, a lot of times I find students that are really confused about what I mean by a signature of the method, what I mean by parameters and arguments, and I kept on thinking what would be a better way of explaining things, and I'm going to give it a shot this time, and you guys need to let me know if that makes anything any clear or not, okay? But before I get to it, let me go through some of the points that we are going to be seeing in the chapter PowerPoint. And of course, that's a good place to start. And then we'll go back and try to understand, try to draw some diagrams and see if we can understand. And then we'll take a break and come back and try writing some methods so that it's easier for you to understand what I'm doing. So over here, it talks about the static class method, the static versus non-static. And remember, our static methods are the ones that are like public static void main. And when we create our static methods, you do not really need to associate that with a instantiated object. However, when you create some of the non-static methods, remember those get set methods, most of the time they're non-static methods. And when you create something like that, you generally instantiate an object and then associate that object with that non-static method. So when I declared employee1 equals new object, then employee1 dot get name, employee1 dot set name is what we use. But when we use a public static void main, we really do not use it. So those are the difference between a static and a non-static method. So we will talk about how these things are applied. We already have seen some of the packages when you are defining your initial program. Some, depending upon how you are starting your program with Eclipse or NetBeans, they would create a package, and package is nothing but putting everything, all the class inside that package. We really haven't gone a whole lot into that, but that's basically what your packages would do. And then, we also look at the access modifiers. What they're talking about is, can I write my methods that are private, public? And then we will also look into the overloading of method. Again, we have already seen a lot of overloading in our constructors. Remember when we talked about the different kinds of signatures? You're having one constructor with no argument, one with multiple argument. So that's the same thing that we're going to be looking over here in the methods as well, because remember, that's also method. Constructors are special methods. So talking about static versus non-static methods. Now, also it's important to understand that in Java, you can have library methods. So sometimes if you're trying to do methods to do some complicated math, you just have to import a library at the top, and there are already methods, okay? So you just call the methods like square root, SQRT. So you call the method and it has a parameter, and depending upon which one you're asking or which one you're using, you have to just pass in your value. So that's what we mean by using library methods. Now remember, with your library methods, somebody else is stored in the library, you import the library package, and then the method works. As long as the method matches the signature, okay? So when somebody writes the method, they'll tell you this is what my method would do, and in order for you to use this method, you have to pass these arguments. That's basically what a method is. So just like your library methods, you can also write your own method. You say, I don't like your square root. I'm going to make my square root method. That's fine as well. And then, of course, this is very, very important. When we talk about these methods, methods with multiple parameters, one parameter, two parameters, how many parameters you can use. And of course, how you declare your method. So they talked about this method call stack and activation records. Basically, what it does is it's telling you that you can have one method inside another method, inside another method. And when you call that method, it gets executed one time. So sometimes you will see that there are nested methods. And we'll try to look into some examples and also see if we can write some, okay? This is a new concept that we will be learning. It's called enum types. So basically, how we talked about when we create our data, variables, we have to specify if it's an integer or a double or a float, So what enum does, it tells you, okay, integer actually means something, right? Integer means numbers without a decimal. They said, okay, with an enum, make up my own root. Okay, so that's what, and we'll look into that. So you can say, okay, I want to create a data type which is going to have only a rule which says it counts the week of the day. So you have Monday, Tuesday, Wednesday, Thursday, Friday. So whenever you call that data type, it's going to basically go from Monday through Friday or Monday through Sunday. So I just define my own data type as an enum type. So you can do that. Java allows you to do that as well. You might see sometimes people use that. All right, and then you have your GUI option. I'm not going into the GUI too much. So why would we write methods? Okay, it has some kind of similar approach towards class objects. The reason you write classes and objects is because your classes are nothing but a blueprint of similar objects, right? You said employee 1, employee 2, employee 3. All these objects that we create, employee 1, 2, 3, 4, have some similar characteristics, and those characteristics are basically your data and your method that then could be all grouped as a blueprint of a class. So if I say, okay, now I'm going to create a class called employee, and every single employee should have an ID, a name, a gender, whatever your characteristics are. Now that characteristics I can create 1 or 50 or even 5 objects which uses the same characteristics. So only thing I got to do is create my object with a new, employee 1 equals new employee, follow that constructor method, and then I can use all the characteristics that I have defined in my blueprint. Okay. Now, in our case, so far, since we haven't started working with arrays, when we said we create 5 objects, we have to write it. Employee 1 equals new object. Remember, when we get into arrays, you can initially declare arrays. You can, in one line, you can say employee and then create an employee 1 object, an array of 1 object, and say 50. Okay. That way, all of a sudden, 50 employees are created all at once. Now, the way you would go inside those individual employees is with the little elements that you go with the array. And when we go into the array, we will get into there. So part of the reason is to simplify your coding, and methods and functions does exactly that. So when you're trying to write a method, a lot of times you will see that they want to break down the method or the function to smaller chunks and write those individual methods, and you can keep on reusing those methods over and over and over again. So you write it and you use it multiple times. Not only can you use it multiple times inside the class, you can then call, if you package it, if you import the package, you can then use it at other places as well. But we generally stick with writing our own methods and using it within the class. But again, the concept is the same. The reason you write methods is because you do not want to repeat the same thing over and over again. Okay? So, software reusability. All right. Now, this is something that you will see when we create our method. Remember how we say that when you create a variable, you can always say int A, int B, int C, but that doesn't make a lot of sense. You would want to create your variable with a name which is a little more meaningful. So if you're trying to get numbers, you can say int num1 or num2, or int first number, int second number. So that's basically what it's in your method. They try to come up with method names that tries to mean something. When you say square root, SQRT, well, in general, people with some math sense will say, oh, that's probably a square root method. So, but you didn't have to. You can always call it ABCD. But ABCD doesn't mean anything to anybody. So that's what we're talking about here, meaningful. So, and you want to break it down. Sometimes you will see that, you know, the big process is kind of broken down to smaller methods inside. Okay. And of course, when you break things broken out, it's easier to test it out to make sure that they are working correctly. Okay. Now, this is the nesting of method. What they're talking about here is when a boss caller asks the worker the called method to perform a task and report back, return to the results of the. What it means is, once you write a method, you then call that method, and the method acts on that particular object or that particular sequence, and then it returns the result back to the calling method. Sometimes you might have nested methods, and it works the same way. It will execute the first one to the outer one, executes the next one, and then go back out like this. Okay. So that's kind of breaking down the hierarchy. You know, if you have a boss method, it's going to call you worker 1, worker 2, worker 3, but the worker can then itself call worker 4 and worker 5, but they have to return it back to worker 1, and the worker 1 returns it back to boss. So basically, that's how the calling works. Once you create something, it calls something, and this one in turn is going to call these two methods, and then it has to report back to worker 1, and the worker 1 reports back to boss. So basically, what you're trying to tell you is, you cannot go from worker directly to your boss. You have to go through this chain that you have created here. All right, so this is where they talk about what your class, your static versus non-static. So it says some method performs a task that does not depend on an object. Does that sentence does the line make sense to you? No? What is it that you do not understand? Sometimes a method performs a task that does not depend on an object. Do you know what an object is? Yes? An object is something that you create out of a class. You say employee 1 equals new employee. So employee 1 is an object. So it's saying sometimes a method, okay, performs a task that does not have to depend on that object. Okay? Then it applies to the class in which it's declared as a whole. So you don't need to have an object. It gets applied to the class as a whole. These are known as my static methods. Okay? Now, the easiest way to remember, I always try to tell people, is public static void main. That's the biggest static method that you always can remember. Now, you do not need a separate object for that. Just say public static void main. Okay? So that main method is a public method. It is static, and it does not return anything. It says void. Okay? It is it's common for classes to contain a convenient static methods to perform common tasks. Okay? So common task doesn't have to be associated with an object. Okay? And of course, to declare a method as static, place the keyword static before the return public, static, void. So void is my return type, static is placed before the return type, and then you have an access modifier, public or private. Okay? So public, static, void main, and then calling a static method, you always call with a class name dot method name. Okay? So another example is your system.out.println. Okay? So basically, println is the method because that's the one with the open and closed parenthesis, but it is associated with an object called out and an object and a class called system. Okay? So a lot of times you will see that they are associated with their class name and then a method name. Okay? So this is your math, and these provides a lot of, so the way you would call the math is you're going to say math dot and the name of the method. Sometimes you would not even have to call the math because you would import the math in your import statement. So that is why you probably would not have to call, add the method. So class math provides a collection of static methods that you enable you to perform common mathematical calculations. And method arguments may be constants, variables, or expressions. Does that make sense? It could be constant. Constant is nothing but a variable, but remember it needs to be all caps. And generally they say a constant, once you write something, you should not change. For example, they say pi. The value of pi is 3.143, depending upon how long you want to have. That's going to be defined as a constant. So every time you want to call that 3.14, you're going to use that constant variable. So a method argument is that the thing within your parentheses. So method argument could be constants, could be variables, or could be expressions like a plus b, c times d. So it could be expressions as well. Okay. So here are some examples of the math class. So it says class math is a part of java.lang package, which is implicitly imported by the compiler. So it's not necessary to import the class method to use its methods. Does that make sense?
So you would import just java.lang?
Right. Depending upon, again, compiler, when you create your public static void, when you create your class, it is implicitly imported. So sometimes if you would not need to separately import the math class. A simple statement which says, if you use a method, okay, and if you write it in your program and you hit the compiler always starts from main method, okay? And it goes, executes the program and runs the process and does the statement. And then it comes across a method name, and let's say the method name is called ABS. When it comes to ABS, the compiler says, okay, what does this mean? It means that there's a method called ABS, and if it does not find it in the implicit package, then it's going to come back and say, hey, I don't understand what ABS is. In that case, you just have to go back and import. And the that we use, the NetBeans and the Eclipse, remember the assist that you give you? So as soon as you type in ABS, you'll probably see a little red mark that said, hey, you got to import your map class. So you just click on it and it imports. But it says, sometimes you don't need to import it because it's included in the basic package. But if it does not, you just have to click on import and it's going to bring it up. Okay? So there is nothing that you have to remember as such, but if you come across some methods that you do not need to import anything, which means that that's already implicitly imported. Just like the constructor. Remember what we said? If I do not define a constructor, Java provides you with an implicit constructor, but that's the one with no arguments. But I can also write my own. All right, so these are some of your math methods that I can use. And remember, it said these are methods. Okay, so I can use this absolute value, ceiling, cost, exponential, floor, and this one gives you an example. With me? So what I want you to do is, you do not have to cover every single method. But I want you to be able, if I give you a list and I said, okay, here is a list of math methods. So I want you to write an interactive program which is going to allow you to practice all these methods. Can you do it? You should say yes, because I understand if I use the absolute value, I need to pass in some kind of a parameter. And it says abs x. So the value that I pass in here, the method abs is going to work on this and it's going to give you a result. Same thing over here, ceiling, and it tells you a little bit about what this method is doing, absolute value of x. So I want you to be able to go to the java.library or any kind of documentation and say, okay, I'm trying to use this method. Let me see if somebody has written something. And if they say, okay, there's a method called this, and it takes this, and this is just an example, and you should be able to use it. You don't have to remember it. Just by looking at the reference, you said, okay, I now know how can I use the abs method. With me? So these are all these methods, and you see a little description over here. Floor rounds x to integer not greater than x. So floor 9.2 is 9.0. Do you understand what that floor does? Okay. Floor negative 9.8 is negative 10.0. Okay. And these are all library methods that are already written for you. You just have to know how to use them. And of course, there's a bigger list here. Log, natural logarithm of x. You guys all good in math? Yes? But here, somebody has already written it. If you want to raise it to the power, look at this. Power xy. So you just have to know. X raised to the power y. So this is also tell you this is how it's going to look. So if you want to say, what's the power, if you want to raise it in power. So power of 2 to the power 7. So it says 2 at the top. So 2 times 2 times 2. So all the way up to 7, 128. Okay. Sine of x, trigonometric functions. Sine of x, trigonometric functions of x in radians. Sine of 0.0 is 0. Square root of x, pass in a value, 930. So these are all the functions that are already written for you. You just have to know how to use it. So you don't have to remember anything. And when I say, okay, write some math method, you can come in, you can choose one of these things, or you can, go to the library and find some other. This one is very, very small list, right? All right. Now, these are some concepts that we have to remember, or understand, not remember, but understand. Okay. Recall that each object of a class maintains its own copy of the instance variable of the class. Does that sentence mean something to you? Or do you understand that sentence? Because we have talked about classes and we have talked about instances. So remember what we said, we defined a class, blueprint, right? Employee. lot of characteristics. String name, integer age, character, gender, all kinds. It can also have some methods in there. Okay, account, name, ID, withdraw, balance, deposit, different kinds. When you create that class, you do not consume any memory. Okay. However, when you instantiate, as soon as you say account one or account check account equals new account, as soon as you do that, you actually take some space in the memory, because that new object that you just created is now going to be able to store some of the general things that you have defined in your class. So an ID, a name, a number, some methods. Now these objects are going to have some space. Now if I create another one, employee 2 or account 2, okay, it's going to take the same blueprint variables, right? Name, ID, age, but it's going to associate that with employee 2. Each of these objects would maintain its own copy. So if I say employee 1 is Abraham and all his requirements, employee 2 could be Nicole with all her things. So each of the object would keep their own copies. Otherwise, when I put in employee 2 dot get name, it's going to return her name, not his name. So that's why individual objects has their own copy. With me? Okay. So that's what it says, that recall that each of a class maintains its own copy of every instance variable of the class. Remember, instance variables are the private methods that you define in your blueprint. There are variables for which each object of a class does not need its own separate copy. Okay? Variables are declared as static and are also known as class variables. So sometimes there are variables that there are variables for each object of a class that does not need its own copy, and in most cases they are common to everybody. Okay, those they do not need to have individual copy for every single one, and the Java allows you to create or write something like this, and those are called the static variables, also called the class variables. Remember, one is the class and one is the instance variable, right? The instance is the one that gets associated with the instantiated object. Okay. You also have things where you can define your class object. When objects of a class containing static variables, remember statics doesn't need its own copy. When they are created, all objects of the class share one copy of those variables. So these are some questions, conceptual questions. If you take or if you sit for Java exam, they like asking this kind of question. So which one actually has its own copy? Do we need to have, when you create an instance variable, does it make multiple copies? And yes, the answer is yes. But when you have a class variable defined, they're actually being shared by all instances. So you have a class variable that you define, and you can define it as a static variable, and then individual objects would share that. They don't need an individual copy of its own. But if you are talking about the instance variables, the name or the ID, okay, they have to have a copy of its own. So the instances can share the class variables or the static variables. All right. Together, a class's static variable and instance variables are known as its fields. And again, these are so if you define your instance variables and class variables all in the class, then they're also termed as fields. And where they're going with this is, remember, everything gets kind of formed into this object or a table or a record. Remember a table? A table has columns. And then there's a row, okay? So that row of multiple columns, name, first name, last name, address, zip, this. The whole thing becomes a record, right? So that's what they're talking about. It's called the field. So that field is basically all the combination of instance and class variables that you define, okay? And of course, we'll learn more about the static fields later on. Okay. So here is an example of a static method, static fields and class method. So remember what we said? We said when we define a static method, it is not associated with any object. You just have to associate the class name, in this case math, and then call this method called PI. Now you pass value in. So math fields for commonly used mathematical constant, math.pi. Remember, this is a constant, and that's why everything is all, this PI is all caps. Same thing, math class name dot E, okay? So this is our constant, so PI and E. Declared in the class math, which modifiers public, statics, public, final, and static. So it's telling you that these methods PI and E is defined in the class math with modifiers. Remember modifiers? Public, private. So it can take public, final, or static. As soon as you define that as a static, then remember this is going to be shared by everybody. Each individual instances does not need a copy of its own. Why? Because this is a constant. Pi doesn't change depending upon the instance of, but instance object's name would change. With me? So yes, I need to know Abraham's name, that object, Nicole's name, but I don't need to know the constant. That value never changes. So that's why you create those static variables, where I don't need to have individual. Remember, this is all memory. You're going to take memory as you define these things. And also, there is something called a final. So if nothing changes, you kind of call it final. Okay, static methods. So kind of already spoke about this. The reason you define a static method is to let the Java virtual machine to invoke the main without creating an instance of the class. So as you say, with the static, you do not need an object or instance created. Okay, declaring method multiple. We're going to come to this one later, but I wanted to go to this thing over here. All right. So over here, let's see if we can understand this code. Here is a import statement right here. And the reason I need to have the scanner input is because of this line number 8, right? So I define a class and I call it maximum finder, okay? Then I have a static void main string argument. I define my input object, which is of the type scanner class. And then I have a system out print line and enter 3 floating point values separated by spaces. Number 1, number 2, and number 3. These are 3 variables that are defined and all done in one line. I could have also done double number 1, comma number 2, number 3. Or I could have done double number 1 equals input next level. So if I had defined it earlier over here, then I would not have to specify double anymore. You understand that? Right. And then you Then you said result, again, another variable, and it called this method called maximum. And this maximum, you need to pass in 3 arguments. Now, another thing I want to tell you, even though there is a technical separate definition of arguments and parameters, I tend to use it interchangeably. You know, sometimes they say parameter, sometimes they say argument, and I can't even remember. When you call it, I think it's called argument. Up, it's called a parameter, but they're basically the same thing. Number 1, number 2, number 3. So here is the method, right? Method called maximum. So when the compiler starts compiling this, remember it starts with string, main method. Then it comes to input. It said, okay, what do I mean by input? Oh, okay. Then I find this input. Say, no, I know what an input is because it's defined in scanner. Okay, fine. Input, new scanner, system.in, which means from the keyboard I can take values in. Okay. Comes over here, system out print line. I understand what that means. Print. Okay, is the method associated with the object out. System is the class. Again, I don't need to have a separate package. It's already done when I create this. I have these values. Okay, input dot next double. As soon as it comes over here, it says, what does it mean by next double? Well, it's already included in the scanner because it's associated with this object over here. So in this package in scanner, there is a method called next int. There's a method called next or next line. So all those methods are written inside this package called scanner. Okay, and I created an object out of this. Does it make sense? Remember when our employee 1, and then employee 1 can use everything from that class, get name, set name, anything that I have written. So same thing over here. As soon as the compiler says next double, okay, what does next double mean? It says it's associated with input. Okay, where is input? Input is in class. It's put it over here. Okay, it goes back and says, oh yeah, there's a method for next double. Next double, no argument. Number 2, input dot next double, no argument. So next double in the scanner, there is a signature, okay, where it says, okay, the next double is not going to take any value, you're just going to call that next double. And then what it's going to do is it's going to take the value in and store it in number 2. Same thing, number 3. Now I say, okay, maximum. And immediately the compiler goes crazy. It said maximum, it's not in scanner, it's never anywhere, so it's going to throw errors. He said, I don't understand what maximum is. Okay, so somebody defined the maximum in the program. It's in the next page. So this is where it's going to say, okay, where is maximum? It's going to start looking. Doesn't find it over here. Look into the end of the program. If you find something, it says, okay, I'm good. And now I understand what to do. So maximum, now you're saying the number 1, 2, and 3. So all this value that you captured is now passed through here. Right? And system out print line maximum is result. So this is what it is. Now you have to know, okay, what is maximum doing? Right? Now, this is also called this information hiding. So if I tell you, Nicole, I have written a method called maximum. Okay? You can call this method, but if you call this method, you have to pass in some arguments. What kind of arguments? Double arguments. You cannot pass in 3 names. You cannot say Abraham, Nicole, and Carolina. It's going to complain, saying, I don't understand what we're talking about, because you need to pass me the right kind of things. So number 1, 2, and number 3. Okay. Okay. The question is, does it have to correspond to these names? Yes?
Yeah.
Yes. Because because this is where you store that value. So when you ask this question, enter three numbers, you put in 37.9, you put in 56.64, he puts in 93.2. So those numbers, 93.2, 56, all numbers, they need to be passed through here. And that's basically why you're seeing number 1, number 2, and number 3. Does it make sense? Okay, now, I could have, let me go to the next page and then we'll come back to the method thing again. So what does maximum do? This maximum, remember, my compiler is going crazy at this point saying, I don't understand. But I go to the next line and says, okay, now I have a method called maximum. So look at my method. Access modifier, public, right? Static. What does static mean? It's a class method. I don't need a separate object to be created for this. And I also, I call this method without creating an object. Double, which means it's going to return a double value. Name of this method called maximum. And then the kind of parameters or arguments I'm going to accept. What? 3 values. So double, double, double. X, Y, and Z are just templates. I can call it A, B, and C. I can call it num1, num2, num3. I can call it anything. So these X, Y, and Z are just variable names to give. But the important thing is it tells you what data type, double. Not a string, not an integer, but a double. Okay? Now, once you take those values in X, Y, and Z, what does it do? It says, okay, I'm going to define a variable called maximum value. Now remember, variable that you're defining, it is local inside this method called maximum. This maximum value cannot be seen from outside, right? So I define a maximum value and assign any X, Y, and Z. I took this first value and stored it in X. Right? So I'm sorry, the value that I take in as X, my very first argument, I store it in this value called a variable called maximum value. And then I have a process. I'm writing an if statement. I'm saying if Y, this value that I'm getting, is greater than the maximum value, then take that value of Y and store it in max value. Correct? Then it goes to the next line. It says if Z, this argument that we have over here, is greater than the maximum value, and remember at this point the maximum value, you are taking that value Z, stored it in maximum value, and then it says return the maximum value. So it actually compared between X, Y, and Z.
So maximum value is Y in the first.
Yeah.
Okay.
So the question is, what is my maximum value? So if I start writing, let me see if I can write on this. Oh, you know what? Is it comma? So here is my maximum. Let's turn this camera around for those of you guys who are sitting outside. Can you guys see both the boards? So double X Z, right? So let's say somebody inputs 56.8, comma 98.2, comma 16.9. All right. See what it says? You have a maximum value. So inside this method, I have a maximum value equals X. Now this should be a double, right? So 56 point now has 56.8. With me? Okay. It goes to the next line, line number 29. You have an if statement. It says if y equals minimum value, and then I have a body here. It says maximum value equals y. So now I'm comparing 98.2 is 98.2 y greater than maximum value. What is my maximum value? 56.8. Is this true? Y is 98.2. Is that true? Okay. So then I'm going to take this y value, which is 98.2, and assign it to maximum value. So what does my maximum value have now? Right? Okay. Then it goes to the next line. It says if Z equals maximum value, then the body is Z is to maximum value. So Z 16.9. So this is 16.9. Is it greater than maximum? What do I have in maximum value? 98.2. Right?
Yeah.
If this is true?
No.
Okay. So then I cannot go inside here. I cannot assign the value of Z into maximum value. And then it says I have to return maximum value. So my question to you all is this. When I pass in these three values, which one do you think is going to return? Because I'm calling the maximum method. Which one do you think is going to return? It says return maximum value. What should I return?
It's probably going to return y.
Y or 98.2.
Yeah.
Right? So, right?
The variable is that's one.
Correct. So here is the confusion sometimes people say. They say, when I said, when I went to this portion over here, and she said, do I have to have number 1, number 2, and number 3? Yes, you do, because what is number one? 56.8. What is number two? 98.2. What is number three? 16.9. Yes.
So, since it's the same signature, then X, Y, and Z, does it never sets the values for X, Y, or Z.
Right. So, this is where I say, this is the part that I set up my my function. So it's up to me to decide that this is what I'm going to call it. I could have called it something different. And I'm going to take in 3 arguments. First of all, 3 arguments, not 2. And those 3 arguments have to be double. Right? This is what I would define those variables. I could call it ABC, XYZ. You know?
But don't you usually have to say like number 1 equals X?
No, that's what I was going to. If you want to call it num1, num2, num3, that's fine. But remember, this num1 has nothing to do with the num1 that you have seen before. They are 2 separate things. So this X, Y, and ABC, it does not matter how you define this. Only thing this is doing is this. When I'm setting up my template of the function called maximum, then I am passing 3 arguments. 1, 2. They are all of the type double, double, double. Now, can I call it A? Absolutely. Can I call it X underscore A? Absolutely. It does not matter. Because when I call this, the only thing I'm saying is, okay, I just need to make sure that I pass in double values. It just happens here, I was, instead of writing the method and passing these values directly, you know, hard coding it, I'm actually asking, please input the value of X, number 1. So this was number 1. So this just happened to be num1. This just happened to be num2. This happened to be num3. Yes? No? Makes sense? Okay. Now, this is a method which takes in 3 arguments. Well, if I ask you a question, what is the name of the method? What's the name of the method?
Public static double maximum.
No. The name is maximum. Right? How many arguments does it take? 3. Or parameters does it take? What are those data types? Okay. Is this a public method? What kind of access modifiers does it use? Public. Is it a static or a non-static method? Okay. Does it return something?
No.
It does not? The method does not return something?
Yeah, the maximum.
It returns a double value. But yes, it does return. That's why it's, so as soon as you see int, double, float, you have to have a return, otherwise it's going to give you an error. Because once you take these things, what you do inside is up to me. So if I had not shown this thing to you, and I said, hey, Abraham, you want to find the maximum of 3 numbers? I have written a method. Just call maximum and pass those 3 values. I don't need to know what I did inside this. Right? So to a group of people, and that's exactly how sometimes these things works in a group. You sit down as a group, you said, okay, what do I need to do? I need to calculate the average of grades. Okay, I'll write a method for you. And you said, okay, I want to read a transcript. And you asked the guy, said, okay, can you give me an average of the grade? He said, yeah, just this is the method and pass these 3 values. and you take that method, you said, okay, now I'm going to return something from that method, and I'm going to write something, a method of my own, which says, if your average is over 90, you got a 4.0 or an 8. Right? So you kind of break it out. I don't even have to know how I created my average. I'm just going to depend on you saying, okay, give me those 3 values, I'm fine. Same thing over here. Does it work? That's what you should be testing. With maximum and I pass in 3 values, does it really find the right one or does it mess it up? If it messes it up, okay, it's a problem because you didn't write the method right. With me? Okay. So let me take a break here. Those of you guys who are outside, can you see? Could you see my writing on the board?
Yeah, I can.
I could switch. I could see it when I was switching screens.
All right. So I'm going to take a break. I'm going to come back and continue with this. So, what is it? No, this time is all messed up. 11:49. Yeah, 10 minutes. So come back at around noon, 5 afternoon.